Recall that objects in motion will stay in motion, and objects at rest will stay at rest when there's no net force on the object. For these objects that are in motion, we're going to define a new term. That new term is the momentum of the object. The momentum of the object is a measure of how hard it's going to be to stop that moving object. So if you have an object moving through space, the object's going to continue to move at a constant speed. The things that are going to determine how hard it's going to be to stop this thing is how fast it's moving and its mass. You can see our object has more momentum now than it did in the first case because she's at a higher speed. Doubling the speed doubles the momentum. If we have a smaller object, that is a less massive object, moving at the same speed as our heavier object, the lighter object will have less momentum. So the second factor affecting momentum is mass. The more mass, the more momentum. The less mass, the less momentum. So to find the momentum of an object, we use the formula momentum equals mass times velocity. The letter we use for momentum is a little p. So it's little p, momentum, equals mv, mass times velocity. Make sure your mass is in kilograms and your velocity is in meters per second. The units for momentum will just be kilogram meters per second. Okay, so we define this new quantity, impulse, as the boost that we give to an object. I can give an object a boost by applying a force for a certain amount of time. The greater the force and the greater the time, the greater the impulse. So if I give this person a force for a very short amount of time, the impulse that they received was rather small. If I apply the force for a longer amount of time, the impulse that they get will be much greater. So impulse, that is the boost that we give to an object, is equal to the force on the object times the time the force is being applied. Mathematically, we say I for impulse equals Ft for force and time. Force is in newtons, time is in seconds, and impulse is in newton seconds. Okay, now I want to show you why we study impulse and momentum on the same day. So we start with the equation acceleration equals force over mass, and the familiar formula velocity final equals velocity initial plus at. Take the velocity initial and move it to the left hand side. You'll get an equation that says velocity final minus velocity initial equals at. Move the t to the left hand side. You now get the change in velocity divided by the time equals your acceleration. Set the two acceleration equations equal to each other and you'll get change in velocity over time equals force over mass. If we then clear out the fraction by cross multiplying, we'll get mass times the quantity Vf minus Vi will equal Ft. We then distribute the mass and we get mass times velocity final minus mass times velocity initial equals Ft. Now you got to recognize that mass times velocity is momentum. So this says momentum final minus momentum initial equals Ft, which is impulse. So the change in momentum equals the impulse. This is why we say impulse is a boost to an object. It boosts the object's momentum.